Okay, example 6 talks about factoring. It wants you to factor using repeated division. So this is another use for synthetic division. It wants us to show that the factors of x minus 2 and x plus 3 are factors of the polynomial function given. So to do this, I'm going to use synthetic division. So I have x to the fourth, x to the third, x squared, x, and then the no x number. That means there's going to be no 0. So 2, 7, negative 4, negative 27, negative 18. Does it matter which one I start with? No. For it to be a factor, if this is truly a factor, x minus 2, that means my last number here should be 0. This is what I want the last number to be. That would mean it really is a factor. So since x minus 2 is a factor, I'm going to use positive 2 on the outside. Drop the 2. 2 times 2 is 4. 7 plus 4 is 11. 2 times 11 is 22. Negative 4 plus 22 is 18. 2 times 18 is 36. Negative 27 plus 36 is 9. 2 times 9 is 18. Negative 18 and 18 is 0, which is good. That means x plus x minus 2 is a factor. X equals 2 is a solution. Or 2 comma 0 on the graph. Now I'm just going to use that same set of numbers and check to see if x plus 3 is a factor. Since x plus 3 is the factor, I use negative 3 as my 0. I should get 0 right there if it really is a factor. Drop the 2. Negative 3 times 2 is negative 6. 11 minus 6 is 5. Negative 15, 3, negative 9. And again, I end up with 0. That's good. Okay. Now it says factor using repeated division, so we're going to go ahead and finish this problem with complete factor. I'm going to raise it up and get the directions kind of off the screen a little bit, and that's okay. I started with x to the fourth. I divide twice, so 4 minus 2 is, that makes this 2x squared. That's why the exponent is 2. And so plus 5x plus 3. And so far, to factor this problem, completely factor it, I know that x minus 2 and x plus 3 are factors. Well, is this the final factor or does it continue to factor? Let's find out. Since there's a term here, I'll do the a times c method with a times c being 6. Multiply to make positive 6, add to make 5 would be, well, 3 and 2 again. Then divide by a, 3 divided by 2, 2 divided by 2. And by dividing by a, I mean divide both my factors 3 and 2 by the a term, which is 2. 2 over 2 is 1, which means x plus 1 is the next factor. 3 over 2 doesn't simplify, so I put the 2 in front of the x, and it's 2x plus 3. So I've done a couple things on this problem. One, I've proven that these two are factors, or are zeros of it, and I wrote them down here. The factors and the zeros have different signs, and I went ahead and factored the rest of the problem. So our polynomial completely factors into that. When we go ahead and try number 53, and it's going to be on a separate video, so go ahead and view the video after you try 53.